All right, welcome to chapter 5 on network connectivity. What we're going to do here is just cover two, call it sub-modules here. Again, to make things easier, I'm going to share a slide deck instead of me just talking. I'm sure you don't want to be seeing me, you want to see the contents on the slides. All right, so again, it's network connectivity, trying to keep this to 30 minutes, but bear with me if it goes. That's contact information, bio, we just keep putting this in there, copyright information. All right, so here I want to describe network attacks and talk about packet flows with access control list and firewalls. The module A specifically goes into network attacks, right? For here, we're going to try and categorize common network attacks, describe cracking techniques, and then again also look at threats to wireless networks. If you recall, everything about cybersecurity falls into the CIA triad, right? So it's good to also classify the network attacks in terms of which area of the CIA they affect, the layer of the network being targeted, and of course, by specific protocols and behavior that is being targeted. So for an adversary, a hacker, they want to do like a recon, an investigation on your network. So one way is what's called an Xmas tree attack, along with fuzzing and banner grabbing. Banner grabbing just wants to know what kind of services you have in there, right? The Xmas attack, when you do a TCP I request, usually have a SYN, ACK, and then SYN ACK, right? So what you could do with the Christmas tree, you just, those are flags, just keep all three flags on. That's what it means. In other words, it's lit up like a Christmas tree. And then fuzzing just means putting like random values or invalid data into the header field, right? To make it maybe confuse the network or do whatever you want to do in there. But also you have what's called spoofing. Spoofing just means pretending to be something that you're not. But specifically here, MAC address and IP address spoofing. MAC address is the hard liquided address, usually on your network interface card. Or in general, let's just call it the physical address on your computer, which is 48 bits, 24 deals with the manufacturer, and 24 for your device. So it's hexadecimal, 0 to 9, A to F. Then the next is the IP address, which would be IPv4 or IPv6. IPv4 is 32 bits, IPv6 is 128 bits hexadecimal, whereas the IPv4 is just decimals, as in 0 to 9, right? So what you could do is a hacker would try to make their own MAC address look like your MAC address or somebody else's MAC address. Same thing they would do with the IP address. So you don't really know whether it's my IP address or your IP address. That's all it means by spoofing, pretending to be somebody that you're not, right? You're just telling that it's really not like an attack by itself, but it's just a tool that enables me to attack you or make the attack a little more effective. So these are doctrines in here. This is about traffic on your network. So the app poisoning, which is address resolution protocol, usually your system to map MAC address and IP address, it has a table. So when I poison it, it just means I'm trying to put something that is not there, like saying you think my MAC address is your MAC address, so you send information. And of course, DNS poisoning. DNS is basically when I type www.google.com, that's for me as a human being to read, right? The system prefers an IP address. And then, of course, the IP address is turned into bits later on. So I just poison the record, so it might go to a different direction. Rogue service just means something that is not supposed to be on my network or it pretends to be on my network. And the URL redirection is self-explanatory, right? Farming is where I'm going to redirect traffic from your site to a malicious site. And of course, the domain hijacking, compromise account. Again, I'm going to redirect traffic. Sometimes URL redirection, farming, domain hijacking are put under similar term, even a DNS poisoning. But just know what it's supposed to do. It's just sending you somewhere else you're not supposed to do, or pretend like my address is your own address, right? The URL redirection It's always before it's called server-side scripts, like on the network server side, not on my host side or on my client side. VLAN hopping. So LAN means local area network. So the VLAN is a virtual local area network. Many times switches use it to separate network traffic, right? So that's just going from one virtual local area network to another virtual area network. So this chapter assumes that you have an understanding about network, but generally local area network is within your house or your office using a switch, whereas a wide area network, right, or between networks LAN. If I join more than one LAN together, we create like a WAN, wide area network, a MAN, metropolitan area network, and I'll use the routers for that. Right, so we segment network to make it more manageable and then for security reasons. So here, this is a general term in here for attacks on the A of the CIA triad, availability. So I'm going to deny you network service. So you can use what's called like a ping flood, which I just send a lot of ICMP packages, means what's called like a ping request, trace route request, just a request to like see, do I have connectivity? Can I reach outside? So if I send you a lot, it's going to exhaust your network bandwidth and then you now shut down. So that's a normal denial of service attack or DOS attack. The one that's called DDoS attack, which is distributed denial of service attack, means I use multiple systems, like computers that have turned into like a robot or botnet. Right? That's what it means. You see the diagram on there? That's what is represented. But a different variation of a denial of service attack, I could send malformed packets, oversized packet, or misuse some kind of protocol. Just telling you that a normal DOS attack targets what's called lower level protocols like the IP address or TCP. Then application level protocols can also be targeted to disrupt services or slow your network packet. So I guess I need to talk about what it's saying here. So if I'm using the OSI, Open System Interconnect, we talk about network traffic in terms of 7 layers. The bottom layer would be physical. You have the data, that's layer 2, right? Network, layer 3. Then you have, so how you tend to describe to my students to use an acronym. All programs seem to need data processing. So layer 7, which is the application, all programs, layer 6, which is the presentation layer, layer 5, session layer, layer 4, transport layer, layer 3, network layer, layer 2, reader layer, and of course the physical layer, which is layer 1. So what he's saying here is like on layer 3 is the network layer, which is where I have packets, and layer 2, and that's where I use routers. Layer 2 would be where I use switches, right? So we have, it doesn't talk about it in this slide, but we have what's called a protocol data unit, PDUs. Each of those layers has a different name. The first top 4 are called data, and of course the transport layer is called segment. And then you really need to know what devices operate on each of those layers. We'll just understand that 7 OSI, as opposed to the Department of Defense, DoD, which uses its own model, which is 4 layers. That's all it's saying here, right? So an exercise in the lab is to launch a DOS attack. Please try that. You can simulate this. You can even do this on Kali Linux and see what you can use. But please don't attack a network that you don't have authorization. Now, interception means I'm going to interrupt, right? I'm going to get a traffic that's going from A to B. I intercepted, right? Maybe I just want to be able to look at your credentials, your username and your password. So I must be on the path of the communication to be able to intercept it, right? The different ways to do it, I can plug a device into the network, I can tap your cable, right? Or get in the range of your wireless access point. Just that's all it means. But the part of the problem here is using what I call unprotected protocols like HTTP, FTP, Telnet, POP. See that right on the bottom. So you want to use one that have the secure protocol. So like instead of using port 80, which is HTTP, I want to use 443 is HTTPS. So I have an S after it, like IMAP S for email. This makes it easier. So on-path attack, which we also call man in the middle, it intercepts and relays traffic between like Bob and Alice. So you think you're communicating with them, but I'm in the middle listening to what you're talking about, right? So it's violating the C in the CIA triad. Some of the techniques would be replay attack, but this is self-explanatory. Like I take your credentials and I go back and replay it or do it again later, right? Or similarly with session replay, in this case, I'm targeting websites, right? Or session hijacking. I take over the session immediately after you log in. Or downgrading, I interfere with the initial network setup, right, to trick you into using weak or no encryption. Sometimes you see this downgrading, like with mobile, I force you to go down from like 4G or 3G down because it's not as secure in some countries, right? SSL stripping is a little more sophisticated. Just understand that now SSL has been replaced by what's called TLS as a protocol, right? And of course, it could be browser-based. That's what this is talking about here. So there are some very really good tools for you to capture credentials on path in a network, right? All right. So first access attack means I'm stealing your password, right? So that's what hackers do. A good goal for hackers to be able to steal your username and your password. Sometimes they already know your username because usernames are very common, like your email address could be your username. A little simple recon online, I will find out the kind of email address an organization uses, which will be usually what they use as a username. So my interest is the password. In the last video, we talked about salting the password and peppering the password, right? But there are many technologies or techniques I can use to try and force myself into your network, right? For physical ones, you see, I can clone your card, access card, or I can put skimmers in the ATM machines. When you enter your card, I can read your card. These are we talked about this first two here, password cracking the other day. Basically, I'm going to look for every possible password in a systematic order until the right one is found. That's the brute force. Keep trying, keep trying. And of course, dictionary, I'm going to look for common words that are used in the dictionary, or basically a list of common passwords that are downloaded from the internet, like a word list. Password spraying and credential stuffing, they're related. Usually with the password spray, just imagine I have like a water hose or something, and I have systems with maybe different usernames. I'm just going to be targeting the users in there, spraying different passwords to see which one I'm going to catch on all those systems, right, at the time. Whereas credential stuffing is, I've got a stolen username and password pairs, right? I just keep trying to put it into a system that particular I want to get in, as opposed to spraying it around. Birthday, this one is based on math. Statistically, if you have 365 days in a year, so if you gather 25 random people in a room, there's a 50% chance that two of them share the same birthday. So this one is trying to attack hash algorithms that are not very secure, or digital signature algorithms, right? So I can get into the system. Rainbow table, we talked about it before, because passwords are stored in hash. I just get a list of password and pre-computed hashes and then try to use it to crack your system. Pass the hash is when I don't need to really crack the password. I just try to use the hash directly. It's a good exercise on the lab to try and crack passwords. Wireless attack, just meaning wireless access point. We all go to the hotel or the airport or even at the school. We use the wireless access point, right? There's a lot of different ways to attack you from that. So I do some recon. It could be what's called a wall driving, wall flying, looking for wireless access points, and I write it down for my co-conspirators. You have rogue access point, which is an access point on your network that's not supposed to be there. And you have the evil twin, which is sometimes confused. Evil twin means like I have, say, Alex Wi-Fi, and you not create another wireless access point called Alex Wi-Fi or something. People don't notice, but it's not supposed to be there, but it looks like an evil twin of a legitimate one. All of these are because encryption attacks is self-explanatory. Disassociation, maybe I kick you off and then you now have to get back, and maybe you end up getting back into mine. And then jamming, you use this to obviously jam the signal. It could also be, you could do the same thing with even drones, jam the signals for drones, jam cellular network. Because Bluetooth is interesting. There's so many different Bluetooth attacks, like blue snuffing, blue smacking, right? NFC, the near field communication for like payment systems. That's why some people use wallets that are like have shields on them. Just be careful about that. Of course, RFID vulnerabilities, radio frequency ID. They have like tags. They're also vulnerable to attacks, right? So this is a good question. If I am trying to say passwords should be lowercase numbers and special characters, I'm basically trying to protect against brute force and dictionary attacks. If I am concerned about on-path attack, you see, what should I try not to do? Because I'm going to be vulnerable, especially when I use public Wi-Fi, then somebody could just be inside there snipping at what I'm doing, right? Amplification of DOS attack, like making it go further or wider, amplifying it. Which of what can let me do that? So you have botnets using computers that have been turned into robots, and I create a network of robots. That's what botnets mean, right? Malform packets, of course, and then a reflection attack. That's ways that I can make it work more. Right? So that's B, C, D. Evil twin, what do we use evil twin for? Usually on path. So you, in the path of your communication, I can see what you are doing. This one here, if you override, so sorry, with DNS poisoning, we don't have to just attack your DNS server. We can attack what's called a host file on your system, right? Host files usually have like IPA address mapped to a website name. Right, so if you know what that is, then it's easy for you to know that that's about DNS poison that we're talking about. All right, flow of packets. So when I'm talking about packets, it means I'm talking about layer 3 of the OSI module, the network layer. Right? So we're talking about routers and switches, what are the security features, and what is the best place to place the firewall. Firewall, think about the kingdom. I have another video of firewall that you can watch on the YouTube channel where you're afraid of an enemy attacking you and you just dig those trenches. You put like kerosene or fuel or tar and you set it on fire. It prevents them from attacking you, right? That's old style movies. But you have what network access control is. Basically, it's a list that are attached to like a resource, like a server, giving permissions or rules about who can access it. Like this guy might say no telnet, no HTTP, or no FTP, or you can have SSH. So I can do it based on maybe protocol, IP address, applications if I want, right? So know this word, north, south, east, west. This has to do with which direction the network is flowing, up and down, and lateral. So if it's going north, south, says it enters or leaves a specific data center, doing like client server traffic. This is traditional data center, right? Most traffic and most attack. This is what you're going to think about, north, south. Whereas the east-west is more like within the same data center, like intra. This is most commonly is server-server communication. That's east-west communication. So the rules for access control can be either implicit deny or implicit allow. Implicit deny is kind of like unless the rule explicitly allows you, you are denied. Access says unless the rule it says access allowed unless a rule explicitly denies it. See, it's kind of like the converse, right? So explicit or implicit, just know what it means. If I don't block you, I'm allowing you to my list, right? So with implicit deny, you hear the word called whitelist or allow list. They've changed it now. They don't call it whitelist, they call it allow list. Implicit allow, it's called a blacklist, or better yet now, a block list. Right? So this is good for like preventing spoofing, because If you have packets with source address that will never be found on a valid packet, maybe I will not allow it, right? Packets with valid address but arriving on valid interface, I could block them. All right, so that on routers, we're talking about layer 3. Switches are on layer 2 of the OSI module. So one thing I can do with switch, and switches deal with MAC address, and we call the PDUs frames. All right, so there's something called port security. You're going to hear that a lot, where if I know a device is going to be attached to that particular port on a switch, I'm basically going to make sure that I'm only going to allow or deny traffic based on the source MAC addresses of those devices that I know ahead of time. Of course, MAC filtering, they call this port security. It's more commonly used for similar features on a wireless access point. DHCP snooping. DHCP is what gives you IP addresses on a network, right, that has a server. You can prevent DHCP servers by doing DHCP snooping, loop protection. You hear what like spanning tree protocol. Something I want to say Spanish tree, right? From all my years in South Florida. It just prevents like loops on your network. Flood guard. This one, examine packets again on layer 3 or higher to protect against additional network attacks. But remember, switch security is generally more on layer 2. So this will be what we want to call a managed switch or layer 3 switch, which becomes confusing. And then MAC security is based on this 802.1 capital AE. It's important to know that it's capitalized AE. Right? In this case, you add authentication and encryption to protocols over the internet, such as doing app or DHCP. Network access control is what you just need to know here is what do they mean, right? How can I configure them? How can I prevent attacks on my network using this? Now, the next thing to know about firewalls. So firewalls, you can have it on your device, host-based, or you can have it on your network-based. That's what that diagram is saying. Network-based sometimes are usually like hardware firewall devices. It can also be software. So know these 3 terms: stateless, stateful, and dynamic packet filtering. Let me deal with the last one. Dynamic packet filtering means that the firewall modifies the rules. It's dynamic based on what it knows concerning the ongoing transaction. This is usually more newer. Stateless, when I get a packet that comes in, right, on my router, I don't know or care whether that packet is the start of a conversation, a reply, or whatever. So I'm not concerned about the state of the communication. I just examine it in isolation. Whereas with stateful, you hear the word about stateful packet inspection or SPI. It's going to look at the source and destination headers, and maybe other things like TCP or UDP, and it will now use that to determine if it's a new communication session or continuation of an existing session. So it actually examines the packet to know which state of communication that is. That's why it's called a stateful inspection, right? So a stateful firewall, look at here, you go into traffic to prevent the attacker, you check what is going on and know is it coming or going. Now, I mentioned that layer 7 of the OSI is called the application layer. So you also have firewalls that work on that layer instead of just on layer 3, right? Or layer 3 and 4. So these ones can be, do you hear the word DPI as opposed to the SPI, like deep packet inspection? They look for irregularities. Sometimes these firewalls are what are called proxy firewalls. In other words, they serve the endpoint of the communication to decide what is going to happen. Like a proxy basically is a server that when you want to request something from the internet, it goes out, gets it, and caches it. So when you request like a website, you don't really get it directly, you get it from your proxy. But it just knows that application layer firewalls, they specialize on servicing like particular applications. They're harder to design and maintain, and they are resource intensive because they are going to check at that layer of the OSI module, so they're going to affect your performance. Now, this term here, UTM or NGFW, new generation firewalls. I don't like when it says that it's almost the same thing as the UTM, but what they mean is UTM is when you have like a small business, you cannot afford to buy an IDS system, IPS system, firewall. So you now buy one device that does all of them, right? But traditionally, the next generation firewalls are firewalls that can do more than the older ones. They have a combination of security. You can customize it individually. So just to understand, but now people are trying to use the term together because the UTM is a combination also. But new generation firewall, initially, they were configured to do more than your traditional firewall. So now you have another term that you're going to come up with the exam. If you hear the word screen subnet, not just for the exam, but you should know it, or demilitarized zone. Imagine North Korea, South Korea. It's the place between the two of them is called a DMZ, right? So normally, you have what's called like a perimeter network, right? But you can also have like a screen. People who live like in Florida, it's easier to remember how you can have a screen porch or something. Imagine this as you screen a certain part of your network. Let me show you with this diagram. So look at this diagram, for example. I've got on the left side of my own screen all these devices, and I've got internet. I put a firewall between my internet and my local network. The three-homed one just means it's got three parts of it. One is going to the internet, one is going to, which is says the one, right? A wide area network. One is going to my local, my LAN, local area network. And then you have the DMZ items, like if you're like, say, Walmart, your file server with your catalogs will be right there in that other section. That's where the DMZ is done, right? And then a dual firewall means I've got two, one between internet-facing resources and the internet. I've got one there, and then one between those resources and my local network. That's why it's called dual firewall. I've got at least two. The lab has configuring firewalls. It's a skill that you should know how to do, both in Windows and Linux. It's not that difficult. Just know that Linux one is a little more, unless you're using like Fedora, but because Linux is like command lane. But if you're using some of the GUI, graphical user interface, Linux is also similar. But Windows, you just type firewall in your search, it comes up. You can do inbound rules and outbound rules, rules that are going out and rules that are coming in, right? All right, so access controls are based on which assumption? Clearly, implicit denial. So in other words, I don't allow you to get in my network, you are denied. I prefer rules that cover everything. So on the last, I might just say deny all when I write the rule. Like maybe allow traffic from this IP address to any of my resources. And at the end, I can just say deny all, which means if you're not on there, you're denied, but I just want to make sure. That's why I'll put a deny all at the end. Packet flow, you configure the router, you want to check the properties of incoming traffic before passing it on, right? So what will this require? Access control is choose best, right? Now look at this DMZ. So this DMZ, you've got that device there. What does it look like based on what we discussed, right? Is it three-homed? It's got three portions there, okay? If I'm worried about app poison and DHCP spoofing, which switch feature could help prevent both? Which is the MAC security. Which attacker activity is east-west traffic control primarily intended to prevent? Remember the east-west lateral movement between my system here to a system on the same, as opposed to north-south outside, right? So east-west control will prevent that. So I know we covered a lot of stuff, but let me kind of show you some things in here just for your, because I'm on a Windows system. But now you understand probes, spoofing, on-path, password attack, wireless attack. You understand flow control, like using the network access control list, switch security features, firewall. Send me questions. We're going to look at chapter 6, hopefully next week, as time permits. Let's see here. So I was telling you about how you do access control. So let me just close a few minutes by just showing you how you could do it on Windows. But if you have access to the lab, you will see that we have some really good labs on there. So let me reduce my screen in here, and I'm going to type firewall. When I have the word firewall on the search, it's the Windows Defender Firewall with advanced security. And this comes up on the screen. You will see on here, it says opening Windows Defender Firewall with advanced security, but it's okay. I'm going to come over here. I'm going to look for options in here, right? If I cannot go in here, I can always say, come back and say firewall rules. Let's say firewall rules. Firewall rules. So if you see on here, I've got Windows Defender Firewall with advanced security. I have Malwarebytes and another one on here. But normally when you open this in here, you can see on the screen, it talks about the firewall. So if you want to turn on a Windows Defender Firewall, you click on here. See on my screen, it's not going to allow you to do that because let me enter my admin password for a minute. Let's see here. So if you're not seeing the screen, it's because I want to enter some. All right, so you see on here, I can turn on and turn off my firewall, right? I can use this to do a lot of different things, but normally I don't want to do anything here. I can turn off Windows Defender here. This is just how you can do your things. Block incoming connections. You can also block all incoming. You can do it for public or private network. Depending on your desire here. If you scroll down in here, this is connected. You can also come over here to advanced settings, and then you'll see what's called inbound rules. If I go to inbound rules, if I right-click new rules, I can do new rules. If I go to custom, I can create the rules based on all programs. And I come over here, I say protocol type. You see on here, TCP, ICMP. I can do all ports, local ports. So basically, this is how you now want to create your rules here. I can put based on any IP address or specific IP address. So this is how you don't do. When you finish creating it, you just save it. And then normally what you want to do is create your rules and then enable the rules or disable the rules. Don't delete them. That's a good practice. All right, I know we try to cover a lot, but please understand the concepts in network connectivity. If you're taking Security Plus, I believe in stackable certification, so I would have hoped you do A Plus, Net Plus, and then Security Plus. Because you had done Net Plus, when I'm talking about the layers of the OSI module, like layer 7, automatically you know what I'm talking about. But that's okay, yeah, especially if you're one of my students at the university, that maybe you're an accounting major or criminal justice major or pre-law. What you just need to understand is networks that are connected or devices connected to networks need to be protected because they are subject to attacks. So this chapter talks about how do we protect them, the type of attacks, or wireless network, or switches, or routers. So you can have a high-level overview of the concept. Understand that because we are all connected today, we need to be concerned about their security. So enjoy the rest of your studies or the rest of your semester and send me questions as always. Or reach me on